Hello everyone and welcome to another video of myself looking at websites from quantum technology companies from the space of quantum computing, quantum communication, quantum sensing and everything around quantum technology. Today we are looking at New Quantum, which is a company I think based in the UK in the space of quantum technology, and let's figure out what they actually do, right? So we are on the website of New Quantum. It says New Quantum is building the entanglement fabric to unlock commercial quantum computing scale out. We see here a device, so probably they are in the hardware world of things, or at least they also have a hardware component, otherwise they wouldn't show something like this here right away. It says a world-first quantum networking unit to scale quantum computing, a major milestone towards distributed quantum infrastructure. Our quantum networking unit is the first industrialized solution for building quantum computing networks via real-time entanglement links across nodes. Modular, flexible and adaptable for different qubit modalities and quantum use cases. So it looks like this component here is an entanglement device. So a device to connect to quantum computers. Now, let's take a little step backward. So the two properties that make quantum computers special are the superposition and the entanglement. Superposition basically says that you can put a qubit, so the quantum bit, into a state where it's like in a superposition or in an overlay of the states 1 and 0, where in the classical qubit we are always either just at 1 or at 0. Here in this case, we can create a wave state, a state where it's basically in a superposition between them, and only when you measure it collapses into 1 or into 0. The other thing is the entanglement. Entanglement means that you create an entangled state so that you basically hook up two of those qubits and they basically share something amongst them, like there is a shared property in a way. So their information is entangled. If one is in a specific state, the other one has to be in the other state, something like that, right? And now these machines here, if I understand it correctly, they help you to do that across quantum computers. So if you have one quantum computer in one lab and the next one in the other lab, you can use such a machine to basically entangle information, so to create a connection, a cross-link between these two systems. If this is the case, that's a very important building stone of, let's say, creating these useful large-scale quantum systems, because, and that's probably worth another video, the number of devices that you can put on a single chip in such a qubit computer, that is of course limited, right? Because you have to make sure that they are cooled down to a specific temperature, like a very, very low temperature. And this usually happens with a cryostat, and that's like a heat pump. And you also have to drive down, let's say, signal signal lines that have to go down to this, for example, superconducting qubit. And the number of lines, of course, increases as you increase the number of qubits. And with the lines, also the heat transfer increases. So you cannot scale this infinitely, because at some point you are just limited by the number of heat or the amount of heat that you can transfer out of the system. So you might have to create two of those systems and then connect them with each other. And if I understand it correctly, this could be a way to do so. By the way, the same is true for these ion traps. Practice shows that like it's incredibly hard to make them bigger and even bigger, because you have to put these ions in a line, like they're in a one-dimensional line. And to create such a system is not that easy technically if you scale up further and further the number of ions in that system. So this could be a very interesting building block in hooking up different quantum computers. And it's also here that you can have different qubit modalities. So it's probably not just superconducting or not just optical control, whatever. So that's probably very interesting to learn more about that. So here it says the entanglement fabric, quantum network plus distributed quantum error correction. Okay. Then we have here the QPU and the QPI, quantum processing units with new quantums qubit photon interface. and then we have the QNU, Quantum Networking Unit. Okay, so yeah, it's really about, let's say, creating this fabric which gets everything together, probably similar to the high-performance compute fabric. Okay, network-enabled quantum computing scale-out. Quantum computing has the potential to solve the world's biggest problems, but these applications require quantum compute systems that are 1,000 times more powerful than those available today. That's what we already know. We have these NISQ systems, right? We need to put maybe error correction on top. That means we need even more qubits. That means we need even more, let's say, even bigger chips. And as I said, that might create a bottleneck at some point, right? The entanglement fabric, our networking architecture for high-impact scale-out, enables data center scale quantum computing by weaving together quantum processors available today. Unlock hardware scale-out. Our technology enables modular scaling by weaving together existing quantum processors with our networking units for distributed computing. Then we have qubit adaptable network. Qubits are integrated into the network via our qubit photon interfaces, adaptable to each qubit modality. And then it says unlock software scaling. The entanglement fabric acts as an abstraction layer, enabling the deployment of qubit agnostic compilation and software stack. Then we see here the team. It says New Quantum has been pioneering quantum networking technology since 2018. Our market-leading expertise is uniquely positioned to deliver a distributed quantum computing architecture compatible with all qubit modalities. And then here you see the probably customers or entities that are working with them. We see Cisco as a large networking company or like network expertise. We see CERN as a research entity, Inflecticon, Airbus, and the National Quantum Computing Center in the UK. Then we also see some investors here. There are various different ones. And let's maybe move on to the technology tab. So technology, and wow, that's a very cool animation. By the way, also this quantum fabric animation was very nice. So they make some very nice looking stuff here. World-class quantum architecture, photonics, and system engineering. So let's see. Our vision, quantum computing's current scale-up paradigm is hitting a wall, and only network-enabled scale-out can unlock the next frontier of quantum compute power. So that's this idea of this fabric, right? Like connecting the different quantum systems. Our blueprint for quantum computing scale-out, the entanglement fabric, is our modular and scalable architecture for a quantum fault-tolerant fault-tolerant quantum computing network, harnessing the principles of abstraction that have delivered today's classical cloud computing. Our approach accelerates time to market and near-term business value for industry. So distributed quantum error correction, that's also very interesting. It says a new approach to quantum error correction. We explore quantum error correction codes that exploit the high level of connectivity and reconfigurability of a distributed quantum computing architecture enabled by the entanglement fabric. So really like using this, like connecting different compute systems via this fabric to make the quantum error correction even more applicable, I guess, right? Distributed quantum computing architecture. Here we see it looks like a high performance supercompute center, and I guess these are like the units that are connecting the different quantum systems. A shift to a scalable solution, data center scale quantum computing power, is unlocked by our networking technology, which waves quantum processors together to form a distributed computer. With subsystems adaptable to each qubit type, our modular approach enables the development of upgradable systems and opens a scalable path to commercial quantum computing. Now, what I wonder is, like it says that you have these different modalities, and I'm not sure if this is going to be answered here, right? But it's just a question that pops up into my mind would be now, can you also connect different types of systems, right? Because I remember a while ago I was doing this workshop of Microsoft. It was the Microsoft Azure Quantum workshop where they explained like how their quantum cloud was working, and they also said that they have these different compute systems in the back end of the cloud, and you can basically choose amongst them. And I mean, now you can do that with a lot of different services. But a question that came up to my mind back then was, okay, now you have this algorithm and you want to deploy it, and it doesn't necessarily have to be a binary transition, right? It doesn't necessarily have to mean like I'm putting the whole algorithm on the superconducting one or on the ion one. How about I only operate those couple of gate processes on the ion one, because this is very good at it, and then I move the information to a superconducting one to execute all of the other gates, because this is much faster in doing so, maybe. And I mean, you can technically do that already if you basically chop your algorithm and you do measurements in between. So you transform, let's say, the quantum information back to classical information and then run it on another quantum computer, do the quantum operations, and then measure it at the end to do some classical extractions again. But this is like chopping an algorithm into smaller algorithms and then running each algorithm again just on one system. But if I understand this correctly, what it allows you to do is to actually move the information without doing this measurement as quantum information into another system. And that would be interesting to also know if you can, for example, take ion-based information and then entangle it with a superconducting one. Okay, let's move on in what they are explaining here. It says a world-first prototype of distributed quantum network control. Our 19-inch rack mount quantum networking units, QNUs, host photonic technology to distribute quantum entanglement across processors. Reconfigurable entanglement like links are dynamically orchestrated and maintained through our proprietary network protocols for distributed quantum computation and control. Here it shows like how this photonic switching layer looks like. Looks like a photonic chip, right? You see like these different couplers here. I guess it's like single photons who are going through these different lines here. You see different elements and like branches where information is merged, and then looks like a switch, right? And it also says switching light to wave entanglement. We develop optical switching and detection technology that can create and distribute quantum entanglement across computing nodes. Built on photonic integrated circuits, PICs, our hardware is designed to meet the requirements of speed, efficiency, and low loss necessary for quantum computing. And then we see here the interface. Extracting light from qubits. Qubit photon interfaces, QPIs, are the bridge between quantum processors and the network, enabling light from qubits to couple efficiently to the networking layer. Our technology is adaptable for different qubit types, and we collaborate with leading quantum computing companies to integrate our prototypes into their hardware systems. So, yeah, how does it work? You basically need like a way to encode this quantum information, right? Like a single quantum information system, for example, a single photon or a couple of photons, like two photons, which are entangled to each other. And then, of course, you also need a detector which can detect this single photon and transform the information that it holds, the quantum information that it holds, like its polarization, back into a system that can be injected into your quantum state of your quantum computer, right? And as it seems, they are working together with the different quantum computing companies, and that would be interesting to know which ones. So let's quickly see if it says something about this here. I don't think so. But yeah, they're working together with different quantum computing companies, apparently, to create those links for the different platforms they have. Okay, let's quickly also check out the About Us tab just to see. Their mission is building the entanglement fabric to unlock commercial quantum computing scale-out. The story, New Quantum, was founded in 2018 as a spin-out of the University of Cambridge to commercialize research generated over the last decade at the Cavendish Laboratory. Since then, We have built a strong IP portfolio and multidisciplinary team to develop market-led quantum networking solutions. We are a growing team of 60 plus across 9 technical disciplines with research laboratories in Cambridge and Harvard, UK, and an office in Los Angeles, US. At the heart of our company is a deep belief in the power of diversity. We embrace the unique perspective that comes from a team of individuals with different backgrounds, expertise, and ideas. Our strength lies in fostering an inclusive culture where every voice is heard and differences are celebrated, where every individual can grow and collaborate in pursuit of shared innovation. And then we see the team here, and then there is like the executive leadership team, the board of advisors, and the rest of the team, which is already quite a big team. I think this is more than 60 people now. Here it says the investors that are basically invested in here. Now, let's say publicly announced, invested in there. And with that, I think let's quickly also check out the impact tab, which says why quantum. Quantum computing represents an exponential increase in compute power to solve global problems that truly matter. And then here we see something like the applications, I guess, that they are targeting. We see that it's about sustainable solutions for a greener planet, a powerful tool for better health, which is probably related again to this pharmaceutical applications. And then we see large-scale optimization for improved efficiency. This is like logistics, but also partially, I guess, finance. So this is like the purpose, I guess, that drives this whole initiatives, even though they are like now at the very, let's say, hardware and probably also the software layer, but not like at the top layer where you go as a consultant to a company and try to figure out what are the actual problems that can later on be run on a quantum computer and where quantum advantage is expected. So here we are more like at the fundamental layers of this whole quantum technology stack. You have the quantum computers, and the promise is to connect those into creating something that is more powerful than today's single compute units are, in order to create something that can really, create a short-term or mid-term, I don't know, quantum advantage. Would also be interesting to understand how far it is, because it looks like it's pretty far already, and how this is gonna work in terms of timeline. With that, I think this is everything about New Quantum for today. If you like the video, please give it a thumbs up. And if you don't want to miss out on the next one, please make sure to subscribe to the channel. I'm looking forward to see you in the next video. And as always, make sure to stay hydrated and see you soon. Bye bye.